Okay, so this is substitution methods continuing from the previous video where we saw some substitutions that can work in for differential equations that are nonlinear, and we found that substitution worked quite well and made it separable. So here we're going to look at another family of differential equations where substitution can work. So sometimes an equation, a differential equation, it may be possible to express it as a function of y over x, where most of the terms are y over x. So let's look at an example where to demonstrate how that can happen. So here's an example of an equation. So you can see here we have 2xy dy dx equals 4x squared plus 3y squared. Now if we divide across by the 2xy or just the xy, we would end up, so you see if we divide across by 2xy, there it is, 2xy divided by it, and then simplify, we end up with 2 into x over y plus 3 over 2 y over x. So you can see here that you can use a substitution, and from that, if we probably rewrite it, it's easier to differentiate it like this. So now, you know, dy dx is just going to be the product of v and x, so it's very easy to differentiate. So you can see we end up with this dy dx is v plus x dv dx. And now one can very easily substitute this into this original differential equation, okay, and that's going to give us, so that's what's, so you can see here, just to show you, basically what we have is over here, this is just, you can clearly see is just 1 over v, because remember v is y over x, so x over y is the reciprocal of that, so it's 1 over v. This is just v, so that's why you end up with 2 over v plus 3 over 2v here, and the entire dy dx is v plus x dv dx, so we end up with this differential equation. Now the advantage of this is that if we take the v, this v to the other side, this one here, take it to the other side, that's going to make this a separable equation. Let's have a look. So, and just bring the minus v to this side, and the 3 over 2v minus v, sorry, 1.5 v minus v just gives you a half v then. So we end up with this. Now of course here, now to separate them, it's better to combine this fraction of 2 over v plus v over 2. Let's do that. There, and now we just separate them, which is very easy to do, and you can see here they're both separated. Just bring this the v to the side of the left side, x and dx go to the other side, and we end up with a simple differentiation, simple integration to do, and that basically can easily be solved. So we end up with this these two basically done. Log of v squared plus 4 equals ln x plus ln c. You can put ln c here or just any constant. It doesn't really matter. It's just a good idea because now you can easily combine them. So you will end up with here, for instance, this this is ln of v squared plus 4, and here this can just be written as ln xc. Okay, x times c. So then v squared plus 4, taking the exponential of both sides, v squared 4 is just cx. Okay, back substituting for v, which is y over x, we get y squared over x squared plus 4 equals cx. And basically, we can clean it up to just y squared plus 4x squared equals kx cubed. So, and that's the solution to this differential equation. So as you see again here in this second type of family of solutions, it depends on the actual differential equation. This also is a nonlinear first order differential equation, and it's as you see here in the start, it doesn't look like it's separable, but using the fact that this division leads to some nice y's and x's, y's over x's, and so a substitution can be made, and it does work. A lot of these type of substitution methods do require experience, and you will only learn how to use these substitutions by noticing that a certain type of pattern exists in a particular differential equation where therefore a substitution could be made, as we saw in the previous one as well. So these are good tools and ideas and types of substitutions to keep in mind as they may turn out to be useful in some equations. All right, we'll stop here. Thank you so much.